My name is Tony Hale. I'm with the San Francisco Estuary Institute, and I'm honored to be associated with Shelly Moore. Shelly Moore, who, as you heard, is with the Moore Institute. She's also employed by the San Francisco Estuary Institute, so just wanted to be clear about that.
Awesome company, by the way.
Awesome what?
Awesome company.
Oh, thank you. So Shelly and I will be kind of doing a bit of a baton passing over the course of today's presentation. So we will go ahead and proceed. Thank you all. We are so excited to be chatting with you today about this project, the California Trash Monitoring Playbook. We have a lot to cover today. We're going to try and go pretty quickly through a lot of material, but at the same time, we do plan to allow for questions. This is the plan for today's webinar. We're going to review the purpose of the playbook, describe the methods, provide an overview of the method evaluations that we performed over the course of 3 years, and then describe the playbook. Finally, as I mentioned, we will leave time for your questions, and that's going to be a substantial part of this, is the back and forth with you, our audience. So we'll try and allow time at the end for that. I am now going to turn it over to Shelly. So Shelly, if I'll allow you to kind of click into the next slide and take it from here.
Alrighty. So we're going to start off by reviewing the purpose of the playbook, and this playbook has actually been in process for quite a while, and we'll talk about why it came about. You know, there's a lot of people doing a lot of things around trash right now. There's been a lot of management focus, particularly in the last decade, around trash. We've had bans, certainly, and the total maximum daily loads. Most recently, we have the statewide trash policy of the trash amendments, and those require some folks to do some monitoring. So there's a need for doing monitoring. There's a need for having some standardized methods. And what we're going to talk about today is specific to a particular habitat, but there's other types of methods that are being used, like the on-land visual method, that do similar things and also meet some of the requirements under the trash amendment. So we'll talk a little bit about some of that stuff. Let me forward. There we go. Yeah, we know that trash has a long history. People have been studying it for quite a while now. The problem is most people do not define their questions really well, and we'll talk a little bit about defining questions in just a minute. We also go into it a little bit in the playbook as well, because it's really important to formulate those questions ahead of time. A lot of times people develop their methods independently of one another, meaning that they go off and they have something in mind that they want to look at, but another group might be surveying the same area and have something else in mind. So there's a need to develop some standardized methods around looking at data and making sure that we can use all of the data to make assessments regarding trash. So back in April of 2017, there was a stakeholder meeting held in Oakland, California. The Ocean Protection Council was involved with that, and we brought together stakeholders from all over California to look at trash issues and talk about what people wanted to know more about. So we developed a list of management questions to basically inform people what was concerning to them. And we also had some recommendations that we come up with a field testing and validation standardization project, and that's what this is part of. And so we got a lot of information out of that conceptual model, and this project was born from that conceptual model meeting. There's a lot of things that came out of that meeting. You can see the list of questions, a lot of different questions. And honestly, people were concerned with a lot of different things all over the place. Questions, habitats were different as well. They basically, at the very end, said, let's focus on on receiving waters, particularly streams and rivers. So that's what this project is about, is looking at methods in streams and rivers. And we wanted to make sure that any method that we looked at, would be applicable throughout any stream or river within California. So there were a number of different things that we decided to focus on, and that was methods that had already been created and investigating new methods as well. So when we think about questions, typically what we think about are, how is my area comparing to another area? And there's no real way of doing that unless we sample both or survey both areas. The other thing that happens is that there are the questions that come up are, is the trash in my neighborhood getting better or worse? Meaning that we need to do sampling over time. And many of the sampling efforts that have gone on throughout the U.S. and elsewhere have been one-shots in time. We have some long-term data sets, Coastal Cleanup Day and those kinds of things, but many of the studies that people do, they just want to find out one thing, they go out and they do a survey and that's it. So we wanted to look at methods that could fit both of these criteria. Next slide. But those are the most simple questions that we have when we're thinking about trash. And one of the things we did at that stakeholder meeting was go over how to conceptualize asking questions. And this is a model that we used for coming up with questions. And in order really to choose which method that you want to use, looking at what the question is very important. Determining what your specific management question is very important in developing your scientific questions, which inform which method you're going to use. So there's a number of different things that you look at. What habitat are you interested in? What do you want to measure? Is it something like, I want to see if plastic bags if the bans are being effective, something like that. Metric, are you going to do it by counts? Are you going to do it by some other measurement such as volume? Pathway, what pathway are we looking specifically at? What's the time frame that we're looking at? Are they decreasing over 1 year? Are they decreasing over 5 years? And we want to know with what level of confidence that we know that that number has changed. So you can see how the monitoring question was developed and the final basically scientific question that we came out of the process with, and we can go from there and develop our method around that. And we can look at what method would best serve to answer that question. Next slide. So again, out of this stakeholder meeting came this project. The funder was the Ocean Protection Council. The State Water Board supported the project, and SFEI and SCORP were leads on the project. It's a 3-year project. It ended officially last year. One of our products was to inform people about the playbook, and that's what we're doing today. Next slide. So our approach, again, was to test 4 methods. 3 of those are already being used by folks here in California, and we wanted to actually test a new method, what we consider a novel method. And we'll go over those in just a minute. We brought together a technical advisory committee, a bunch of trash experts. Some are on the phone call today, and they advised us, and we reported to them at the beginning of the project. And after our first sampling season, we got some feedback from them and went out and did some more sampling. So we had a lot of input from them. And along the way, we involved many stakeholders. The products from this project specifically are a field testing report, basically analyzing the sites and the data that we collected. We did all 4 methods at different sites throughout California at the same time, so we could compare those results. And we have some of those results here for you today. The second product is the playbook for trash monitoring. This, again, is specific to rivers and streams. It includes standard operating procedures and a number of other things that we'll talk about as we progress through this talk. Another product was outreach and training, and we wanted to make sure we got the word out about this. We want these methods to be available to all kinds of different stakeholders to use and collect data. So we've got at least 4 standardized methods that people can follow the SOPs for and come out with some important data. Next slide. I will pass it to you, Tony.
Thank you, Shelly. That was a great introduction. So now we want to provide a little bit more detail about the methods that we used as a basis of validation. I should say that we did put a lot of thought into the methods that we selected, and the ones that we did select had to meet certain criteria, but there could have been other methods that could be added to the mix, most certainly. But what we were looking for these methods were things that had already broad adoption, and so therefore would benefit from this intercomparison, because the impact of the analysis would essentially be guaranteed by virtue of its already established audience. And it had to be practiced in Northern and Southern California, since this was a California-wide project. It needed to have kind of the bona fides of scientific credibility. So what we, just to kind of now dive in, the methods consist of a qualitative assessment that you would call a rapid trash assessment, as well as 2 other quantitative assessments, volume-based as well as count-based for the different trash, and then a novel method. And just a word about the novel method, why that's placed into that, especially given the criteria. We knew that there were certain constraints, certain limitations that people face when doing trash monitoring, some of which are very practical, not being able to get out as often as you'd like, not being able to cover as much space as you would like. And so we wanted to take this opportunity, particularly as we're performing multiple methods in the same assessments, in that same frame of reference, to capitalize on those different measures of truth and develop a new method that would ideally address some of those already known shortcomings. So beginning with the first one, the qualitative assessment, this is a visual observation method. It is used, different variants are used in different places, but it really comes from the Surface Water Ambient Monitoring Program's Rapid Trash Assessment originally, that was developed for land-based situations, but it's since been adapted by EOA and BASMA for receiving waters, creeks, rivers. And it's based on a qualitative scale, 1 being lowest amount of trash, 12 being highest. So that's not a measure of bad to worse. It's the opposite. 1 being the lowest amount of trash, or good condition, to 12 being the highest amount of trash, or poor condition. And you can see some illustrations here that are used often for reference to build consistency in assessments. Another form of monitoring is a volumetric-based method. This is trash measured by volume. So this is a method whereby the trash practitioners will survey the site, they will extract the trash, and then measure it. The current method calls for measuring according to determined pathway. So looking at things and saying whether it comes from stormwater outfalls, direct dumping, wind-blown litter, etc. So they measure according to pathway. However, along the way, we recommended a change, and we use categories aligned with material types that are in common with other methods. So as you're gathering up the trash, you can just take the entire trash and say, we found, let's say, 20 gallons of trash. Or you can break it into categories. And so when we're talking about these categories, we're talking about material types like plastic, metal, wood, etc. And we found that volume is particularly advantageous for dealing with receiving waters, because things can be inundated as they're wet. So in other assessments, particularly on land assessments, you might measure things by mass. This is often how trash management agencies might measure their loads according to mass. Volume we found to be a lot better in this situation because it's more consistent, given that things can be wet and inundated, and suddenly now they might weigh 4 times more than they would if they were dry. Another method is a quantitative method, also called the Stormwater Monitoring Coalition tally method. This has been in use for the last 15 years or so, and it facilitates the counting of individual pieces of trash by material and item categories. So deciding if it's plastic, and then if it's a plastic bottle, or it might be plastic bag, or it might be plastic some other type of item. And this is particularly effective in getting very, very granular so that you can measure change over time for the trash load in a given location as measured by counts, and you're measuring those specific items that you may be interested in. So if you have a bag ban in place, then this would be an instrument that you can use to drill down and determine the change over time for the presence of bags in that location. As we mentioned, there's also a novel method. This is the unoccupied aerial systems method, whereby we flew a vehicle that you can see pictured here. It's a propeller-driven vehicle that flies anywhere from 100 to 200 feet above the landscape, and it's able to capture imagery for analysis later. Important to note is that the imagery that we were collecting was timed with the assessments we were doing on the ground, and so we had a basis of knowing exactly what was in the location. The goals for this would be, as I mentioned before, there were a number of constraints that people routinely face with doing trash monitoring almost universally across multiple methods. And expanding the geospatial range is key. So if you have a certain number of people, you can only kind of monitor so much. So being able to monitor more with fewer people is one thing. Being able to get out more often, so increasing the temporal density. Enhancing the ease of data collection, so being able to do so without putting yourself or others in danger, as if you're kind of wading through water or in areas that may not be safe, or areas that may be sensitive on the other end, that you don't want to traipse over sensitive habitat perhaps, or areas where there may be other concerns, exclusionary concerns. Also, being able to automate counting is part of that ease of use, and improving repeatability. That is, using the very same mechanism for doing counting. This was done via imagery manually, so having people who were not there look at the imagery and determine how much trash they could see in the imagery on a manual basis, as well as performing counts automatically via artificial intelligence. So we would fly above the ground to maximize the area covered. Generally, you can think of it as a trade-off. That is, the higher you fly, the more area you can cover. The lower you fly, the better the resolution. And you could cover more space than you can if you were on foot. And we also use flight planning software in conjunction with the flights so that the flights can be repeatable. And you can do the same flight in quick succession or even after many years and visit and to see change over time, and have a very precise measure of where you are flying. And now I'm going to toss it back to Shelly.
Awesome. Thanks, Tony. So I'm going to talk a little bit about the method evaluations that we did. And certainly we did a lot of evaluations. We looked at a number of different things. Thanks, Tony. And one of the things I want to say is that if you really want to see all of the method evaluations, you'll have to look at the field testing report. I will demonstrate or show some of the graphics that came out of the comparisons, and but certainly not all of them. So we wanted to look at, since we were performing each method at a given site, we wanted to look at how accurate each method was. Meaning, if I sent somebody out there to do the survey, were they going to get everything? How close did they get to getting everything? If we sent a number of teams out there to do the same site, how close were their numbers going to be? The other thing that was that came up a lot when we talked to folks who were already doing some of these methods is, this takes a lot of people time. This method is very labor intensive. So we wanted to look at how many resources were involved with doing each method. We also looked at how well the methods performed against one another, and looked at whether or not one method could be predictive of another. If you go to a site and you count 500 items of trash, would you be likely to get the same visual assessment score based on the number of items, or going the other way? If you went and you measured the volume and you had a half a gallon of trash, is that something that's going to be comparable to something like the visual assessment score or the tally, the number of items there? So we're going to present some of those results here today, but I encourage you to look at the field test report if you want to know more. Go ahead, Tony. So our goal was to fill in this table. We wanted to know, based on monitoring questions and the method, whether or not there was a lot of bias of error built into each method, whether or not the methods were repeatable, meaning we could send a team out, they would do the assessment, and then we'd send another team, and how close the numbers were. Again, we wanted to look at resources, how much cost was involved in determining whether or not it would be a consideration for folks to determine whether or not they'd use that particular method, because there are limits on resources these days. Next slide. So this slide represents what we did to look at the accuracy of the tally method. This is something called an extinction curve, and basically what it measures is the number of passes it takes a team or teams to do on a site and get the true number of trash, the true amount of trash that is at that site. In most cases, 2 passes will work. You can see the number drops down greatly after the first pass to the second pass. But for some sites, it took 5 attempts to get all of the trash at that given site. I will say that site 1, the one that had the most trash, the highest amount of trash, was the site that you see pictured on the right. And just looking at the site, you're not going to see a ton of trash. What that meant was we found a lot of small trash. As a matter of fact, all that small trash fit into those buckets right there. And what we saw in general was that the smaller the trash was, the more passes you had to make as well. So site 5, on the other hand, had relatively larger trash, and most of the trash was picked up after 2 passes. Next slide. So this is a comparison of different teams. This is, we had 3 teams at a site. They all did the assessment, and this is our measurement of precision. And you can see that the 4th line is actually when we actually picked up all the trash, took it back to the lab, and counted it there. And you can see that number is the highest total when we took it back to the lab. And that could be due to a number of factors: trash breaking up on the way back as as we collected it, breaking up within the trash bags. But you can see there's a little bit of variation in the amounts of trash that everybody counted. And one of the things that I will say that came out of the method comparisons is that training really does make a difference. The groups that were out there, some of those folks were trained, some of them were not, and you can clearly see the difference in the amounts that they collected. Next slide. So the third thing we looked at was, are there any relationships between the 2 methods? And one of the things we found is that, and the BASMA folks up in the Bay Area did a similar study. They found that volume and the visual assessment typically are very close to one another. They've got a pretty high R-square, and you can use that visual assessment in lieu of the volume assessment in most cases. Next slide. So here I want to talk a little bit about the UAS method, the novel method. This was actually all very new to us, and we had a great pilot go out and fly different areas. And what you can see in this picture, it's an aerial shot, but all those green dots represent boxes around items that were identified as trash or identified as something. So if we were to zoom in on a particular area, for instance, in this case, we can look at what the trash consisted of. You can see here there's a toy, a wrapper, a water bottle, some different types of items. And let me start by saying these particular pictures are from an area that was seeded with trash. So we took the trash out and we put it in this area. We flew over the top and collected the information.
Shelly, actually, just a quick correction. That's
Sure.
not right. This was actually the way we found it.
This is the way you found it?
Yeah,
okay.
we have another example that's seeded. This is as crazy as it looks. This is what it looked like.
Yeah, I thought it was the seeded picture, but it's not. Okay, so this is actually an actual site with some trash, and we had folks go through and identify all the trash in the imagery. And really what we wanted to do was compare it with what if everybody went and picked up the trash and counted the trash. So next slide. So these are some of the results. And essentially, if you just went out and you flew over, had somebody identify the trash in those pictures, the number on the left under nothing is what you get for the imagery. And when you have somebody walk the site and pick up all the trash, what you get for nothing is the bar on the right. If you exclude all the small pieces that those trash practitioners picked up, the numbers get closer. And if you exclude pieces and paper, the numbers come even closer. And what this indicates is that the UAS method is very effective in identifying the larger pieces of trash, not so much with the smaller pieces of trash, particularly in a vegetated area. If it had been in a concrete lined river or stream, the numbers perhaps would have been different, but oftentimes we've got vegetation that will cover and obscure some of the trash within a given site. Next slide. The other thing that we wanted to mention, and there are some sections in the reports that go over some of this stuff, are that we actually partnered with some other folks. The California Department of Public Health, we developed a tobacco product waste method working with them, and that report came out just a little while ago. We can direct you to that link as well. And we also worked with a graduate student at the Loyola University in Chicago. And the student was doing trash assessments similar to what we were doing here in California, but a little bit different. So what she did was she actually performed some of our methods in Chicago in their streams and rivers to see if the methods were comparable between the two areas, between California and Illinois. We also had partnerships with some supercomputing organizations, and they were essential in doing a lot of the UAS imagery analysis, and they were really kind in providing us with some supercomputing tools that we could use in order to process all those images. Also, we worked with the ETAP folks at the US EPA. The Escape Trash and Assessment Protocol was a method they developed for going out and assessing a whole bunch of things about trash, counting the trash, assessing how hazardous the trash was, all kinds of different things. Their protocol was very labor intensive, and we'll talk a little bit about that in the reports as well. Next slide, and I'll pass it back to you, Tony.
Thank you, Shelly. So now we're turning to the playbook itself, and we want to describe some of the things you would find within the playbook. So what we try to do with the playbook, we talked already about the overall goals. And so to achieve those goals of the kind of overarching goal of helping to guide people from monitoring questions to the appropriate methods, we provide some considerations of the field sampling, realistic field sampling circumstance. So getting site access permits, permissions, other considerations, the types of equipment you need to bring along, including safety equipment, being aware of dealing with invasive species. And then we step into different quality assurance requirements as well. This involves training materials, how to ensure that you are able to promote the highest levels of precision or repeatability, how to do field audits, how you can, to what degree you want to walk the same areas to promote consistency among your assessments, and then how to review the records that you have collected during your assessments. We also talk about promoting consistency for among the different methods in terms of training, common vocabulary, and I see that Wynn Cowger is on the line. I can see you, Wynn, believe it or not. Hey. And Wynn has been very instrumental in drawing everyone's attention to the importance of taxonomy and vocabulary and having consistency among different methods. And so we've taken a lot of inspiration from Wynn and his efforts. And then another thing, as far as within the under the moniker of consistency, we ended up recommending amount per unit area, also kind of known as density or concentration, as a measurement that can help promote inter-method comparability. So if you think about it, even some of the qualitative methods that are looking at a qualitative score from, let's say, 1 to 12, what they are doing is measuring a density of trash. That's explicitly within their guidelines, is that you are mentally assessing how much trash is in this area by virtue of density. So we recommend leveraging this amount per unit area as a way to bring comparisons together, so that even when you are practicing different methods, you can do that form of translation. And we've had the benefit of working this through a number of different, working this idea through a number of different fora, including a trash hackathon in the context of uploading data into public repositories. Also included would be some things diving into more into the data management world and data standards. So field forms, of course, are that kind of thing that helps to facilitate the collection of the data. So that's very important. We also provide links to the data themselves that we collected in the course of the project. So if you want to, particularly if you want to consider the field testing report that Shelly mentioned earlier, having your hands on the data would be very useful, and those data are already available on the Contaminant Data Display Download tool at cd3.sfei.org, but we'll have links to that within the playbook. The machine learning algorithm that we developed, so when Shelly mentioned that we had the support, that we enjoyed the support of different organizations such as Oracle and Connecticut, we actually applied for and received companion grants that did give us those resources, and so we were able to build this machine learning algorithm, which we are now in turn sharing with you. We also developed a template for a mobile application under Esri's Survey 123 software, recognizing that what we wanted to do is to have consistent data collection, so skipping the whole paper step. We wanted to start digital and go pure digital to digital conversions. And so using a mobile app to do data collection was for us just a quality control mechanism, and we are now making that template available to you. We also share with you an SOP, or standard operating procedures, for each method. And another key concept is the way that we've tried to tier the methods. The tiering is meant to be a kind of framework for understanding the relationships among methods and the types of questions they can address. So that's what we're going to discuss in the following. So this tiered method approach, what we see how this would operate is that the methods can be kind of like, you can regard the tiering as kind of scaffolding, and methods can be placed into the scaffolding. So beginning at the top, this tier 1 visual, and I should say, first of all, just a caveat here, is that the tiers do not reflect utility. That is, you may opt for tier 1 and it may be perfect for what you need to do. You may opt for tier 4 and it may be perfect for what you need to do. It is about mapping the monitoring questions to methods and understanding kind of how they fit in to the types of things that they are analyzing. And so the tiers are meant to reflect that, not how useful it is or how sophisticated they are. But tier 1 is a qualitative method. Low, moderate, high, very high is kind of what is the one main thing to come out of that. The tier 2 is the tier created to house this remote sensing tool. So this it is a very general category of plastic, not plastic. The reason why we did that, instead of going into great detail about the different types of materials, we wanted a way to judge whether we were successful in the broadest sense of identifying trash and not trash. And so being able to do that at this stage while we're developing this algorithm is of utmost importance. So that's why we started with a general identification. But if you want to get more granular, then the volume method, as we've described it, associated with material, plastic, fabric, and cloth, so on, is a way to have a measure of volume as extracted from a given assessment area. But even getting more refined would be within those material categories, you also have the specific type of item. So what you see here mapped out is under plastic, there are these items. I should say this is not exhaustive. So there are something like 70 different items on the tally sheet, but this is meant to be an example of the types of things you might find under each of these material types. Now, these relationships that we've painted by virtue of these tiers are kind of new to the playbook. They are found only in the playbook. This is something that is evolved out of our testing and validation. These different methods don't necessarily recognize these relationships, but we're hoping that this framework can serve as a tool for selecting the right method for you. So examples of the types of questions that might be attendant to these different tiers. So tier 1, if you think about this being that qualitative score, how much trash is in my stream or river, in which of my receiving waters is trash most prevalent, and how does my area compare to others? So these are fairly general questions that might be scored according to this qualitative measure. So when we're saying how much trash, that is going to be reflected in a qualitative sense, not how much trash in terms of how many items, how many plastic bags, that kind of thing. That's not going to be addressed through a qualitative score. With tier 2, as you may recall, this is the remote sensing via the unoccupied aerial system. This is where you can get to pieces. So how many pieces of trash are visually countable across a very broad landscape. So the elements of this that are operative here are visually countable because, as Shelly pointed out, if things get too small, then you can say that that's below the minimum recognizable standard for what can be seen. But the trade-off is that it's a very broad landscape, so you're able to see further. How does the amount of visible trash vary according to landscape conditions at a broad scale? So this is where you might be able to do broader assessment of the site and judge how the levels of trash compare to either the site conditions themselves or where they are situated within the landscape. And if you're able to do more assessments over broader areas, you may be able to do determinations in ways that you couldn't otherwise if you had to pick and choose where you would go. So tier 3, this is that volume measurement, just to remind you. And so is the volume of plastic increasing or decreasing in the study area? And another question might be, does the trash volume increase in the study area following a storm event? So this is all contingent on performing these methods according to the training with the right guidance. But being able to get out there and extract the overall amount of plastic and be able to do so at certain intervals would allow you to answer that first question. Being able to do the kind of before and after storm event assessments for trash extraction would allow you to answer that second question. In Tier 4, as you may recall, this is the method for tallying individual items. So this is where we're getting into a finer level of distinction. Is the amount of expanded polystyrene increasing or decreasing? So a lot of times if you are interested in a particular product, that's where getting individual counts of those items is so very important. Has the expanded plastic bag ban reduced levels in the study area? So in this case, you're interested in plastic bags, and there was a ban that was a management action that was taken, like a ban, and so you want to know if that ban was effective. Something like a tally is really the only way to get to that level of resolution that can be useful to inform that management question. So among the things we've done is to fill out that matrix that Shelly mentioned earlier. Omitted from this are the questions, and that's because we kind of broke it out separately. But what you have here are the different methods, levels of accuracy and precision that you can expect based on our testing, as well as the resources necessary to do each of these methods. And we do have some discussion within the playbook about this. But you can see that as you're going further down the tiers, it gets more expensive, but it also gets higher accuracy and precision. More expensive for the size of area that you can cover. And as far as another way to frame how to choose your methods, moving from management question to monitoring questions, what Shelly mentioned right at the very top of this presentation, but then taking into account the available resources, the expected levels of accuracy and precision, allows you to get to a method which can then be selected from the tally, volumetric, qualitative, or UAS-based methods. In addition, this is an example of that mobile application that I mentioned earlier that's based in Esri Survey 123. And some of the advantages here are that it automatically structures the data, so you don't need to provide that structure. And it embeds teaching tools for informed interpretation. Just to pause on that for one quick second. What that really means is that a lot of times people go out, they've been trained in the method, they go out and they perform the monitoring, and they may have resources, paper-based resources that they used in the course of their training, and they may consult those, they may bring those papers along, and they are encouraged to do so. What the app does, this survey does, is it places those resources in a digital form always at your disposal in the context of data entry. So if you want a reference image for what does a low trash level look like, you can pull up that reference image, such as the image that you saw earlier in this presentation. Or if you conversely want to see a high level, just so you can kind of have those reference values in mind, you can pull them up. They don't take extra space. They take digital space, but certainly they don't weigh anything. So you can bring that along, and it's always at the ready. So having those teaching tools, as well as then understanding the matrix, some different matrices for assessment, can be very helpful. It also automatically collects location data, or I should say not automatically, but you say record it now. But it's woven into the actual Esri app, as you would expect, being a geospatial company. So that's a powerful synergy there. And it collects imagery in an easy fashion. So rather than having a separate camera, then you're able to do that. Also, active connectivity is not required. You can download it, and if you have to go to areas where you don't have an internet connection, you're in an area that has no cell reception, etc., then you can still use this tool. So there are some real distinct advantages associated with using a tool like this. We're not prescribing that you need to use this template, that you need to use Esri's Survey 123, which, by the way, does come with cost. But this is something, the template itself is available to you, and you're free to use it or develop your own tool based on it. So some of the findings and conclusions among the first is that size matters for all methods. We've discussed some of those things, such as the ways that the extinction curves reveals that when you start to get to the really small scale, people tend to overlook those things. And so size really does matter. Costs vary by resource type. So as we're thinking about how to evaluate costs for UAS, that's very different for having volunteers go out and do visual assessments or rapid assessments. And so there's different ways to think about that, which you can see described in the playbook. And we found that by weaving together by doing the methods in the same place at the same time with different teams, we're able to show how the relationships among methods do lend themselves to a correlation that you can say can predict results. So there's promise there that you can crosswalk some of these methods one to another as long as you're dealing with trained practitioners. And that the trash density metric can also facilitate broad comparability, as I've mentioned before. But all of this is contingent on training. Training, we found, is critical for repeatability. Where people were undertrained or very new to this type of work, it was less repeatable than if people had the necessary training. So we're often asked which method is best. And you saw me earlier when I was talking about the tiers. I put caveats around that, saying that the tiers are not reflective of necessarily that tier 4 is better than tier 1. And that's because it really is about the management question that you have. So if it's all about suitability, and so if your management question is of a general sense, thinking back to some of the questions we associated with the qualitative scores, so how does this creek compare to others in the area for condition? If you, Shelly, did you want to jump in?
I just want to let you know there's 5 minutes left.
Whoa, time goes fast. Okay, so the idea of which method is best, that's that really has to take into account the types of questions you have. So now we're in the question session. We only have 5 minutes left. We planned to move a lot faster than we did, but we hope this has been useful to you. The main resource we want to point you to, just while we have you here, is trashmonitoring.org. That website has not only the trash monitoring playbook, and which will be available on Monday. So if you wanted to go and download it, just if you can hold on for 1 sec, we just need to have someone review it before we release it. So it will be released on Monday. So we're begging your patience, but if you can just remember to come back on Monday to trashmonitoring.org, you'll see it then, along with the field testing report and the resources that we mentioned in the course of this presentation. My email address is here, Shelly's is here, and we really want to allow the remaining time that we have, which isn't very much, for questions you might pose to us. Thank you very much.
Thank you, Tony. Thanks, Shelly. We can extend the Q&A as long as you would like. It's up. My time is your time, Tony and Shelly. We had one question come in via the chat, and it was, were you guys monitoring trash items under 5 millimeter?
No.
No. Not really. Go ahead, Tony.
We were influenced by the definition of trash under regulation, where 5 millimeters below that is microplastics or micro debris. So we define trash as larger than that.
Thank you. Another question coming in. You noted that team training made a notable difference in accuracy of trash counts. Did untrained teams typically tend to overestimate or underestimate during the assessment?
They typically underestimate. They don't have the search pattern down yet. They also don't know how to identify things. There's a lot of new items popping up in the field all the time. One of the things that Tony and I learned about was electronic cigarettes when we were working with the CDPH folks, and we never knew that there was such a wide variety of electronic cigarettes, and they showed us some different different types, and it was amazing. And we wouldn't have known what those were in the field. So it's an ongoing challenge to identify things. I know, for instance, some folks have told me that they're finding more dental picks in rivers and streams right now. And so I think that's why it's important to do things like the tally method, so you can identify some of those newer types of trash that are out there. I think Wynn had a comment and a question as well. It says, so UAS is typically underestimating the tally. I wonder if there's some metric associated with the vegetation of the site which can be used to correct the numbers. Also wonder how accurate the classification is by trash type. Are some material types poorly characterized by UAS? Did you want to take that one, Tony?
Yes. I'll try and be quick about it. So the most important factor that determined how well the UAS would identify things was not just the size of the items. That was one key element, but it was also what we would call the scene. The scene is the background information. Seeing paper around rocks, white on white, is really hard. So when the scene is what you might call confounding to the visual representation, it was very hard. However, I should note that Shelly mentioned the work that we did with the tobacco control program, where we developed another algorithm which we didn't share here, but it was detecting cigarette butts. So we got very specific, and with that, instead of having a 50% success rate, we had 98% success rate. But that was because we controlled the scene very carefully, so we were looking for cigarette butts on asphalt. And when we were doing that, we had a tremendously high success rate.
Yeah, and I will add, Wynn, that we did look at vegetation, so as well as BASMA, relative to the amount of trash that we were finding, and there doesn't appear to be a real great relationship there. So it's going to need some more investigating, because I would have expected there to be a better relationship, just because of the nature of how the vegetation tends to catch the trash as it's flowing through the area.
Thank you. We had a question come in from DOT asking, did you do any monitoring along a highway or state route? And then asking for advice for monitoring freeway trash conditions with high-speed traffic. Maybe that's a UAS application, Tony.
Yes, so I can address those questions. So Walter Yu with Caltrans reached out to us very early on in our project and was instrumental in some of our thinking about the development of our machine learning algorithm to detect trash. We weren't really overlapping as far as the places we were looking. So while Walter was concentrating on the highways, as you would imagine, looking at the freeway system and how to do those high-speed assessments that Cornelis is interested in, we were interested in being in the creeks and rivers as per the stakeholder workshop that guided us. So we weren't on the land per se. We were working within the context of a different habitat. However, I should mention that Walter did, with partnerships with others, develop a algorithm to detect trash moving at speed. Moreover, in the Central Coast, Second Nature is developing an algorithm based on still images taken in series to detect trash while people are in vehicles. So there are projects underway to address those needs, to detect trash on the streets. And then we also had the benefit of the Water Board association with the West Sacramento street sweeper imagery, and they shared some of the imagery they gathered through a rear mounted camera attached to street sweepers looking down into the gutter. So we used that to train our algorithm for the cigarette butt work that we did.
Thank you. We have two more questions came in. Which of these methods is most sensitive to trash category size?
Sorry, can you repeat that? Which one is most sensitive to trash category and size?
To trash size categories. That's, yeah.
Okay, right. So that's a great question. So as far as the trash size categories, the tally method does have have ways to distinguish the large and small items because they are classified according to their what the items are. So in other words, you know that what approximate size a shirt is versus just cloth. So being able to get down to the level of an individual item can give you some predictability about how large it is. There's also places within the volume method and other, well, I guess across the board for all the methods we tested, where they can indicate items that are too large to extract. So things like shopping carts or vehicles or things of this nature. So that's of a size category that's beyond what can be extracted. They're noted and counted, but they aren't necessarily extracted and measured according to the strict rules of volume calculation. And then if you get to the other end of the scale of the very small, within the tally method, they do estimates of the very smallest items. So when you're thinking about, this is where you're right on the cusp of what 5 millimeters might be, but if you think about a polystyrene igloo type of container that's maybe degrading, and so it's being shredded over time, and you have to count that. And you know, it's in pieces. So if you have all those pieces, you can estimate a certain range of number of the smaller pieces that you would find. And so there are places on the tally sheets to indicate when you found some of the very smallest items. So I hope that that's gotten to it, but Shelly, do you want to add anything to that?
No, you answered it very well. Yeah.
Okay. Ramel from US EPA asked what we're all looking at in the photo that you see on the screen. Just a quick answer to that is that Pete there on the left in the fluorescent vest, and he always wears that so he looks more official. He's flying a what you might call a drone or an unoccupied aerial vehicle, and you have Sherry Lippiet at the far right, Shelly and I in the middle, and we're all watching the drone fly over a wetland in Vallejo, California. So it's flying at about 100 feet, and we watched it take off in front of us, and it's surveying that wetland.
Thank you, Tony. Do you see a question from CalRecycle posted?
Looking.
Yeah. To what extent are uniform measurements and detection methods statewide, nationwide needed in order to push evidence-based policy development forward? So it's circling back information to policy and what do we really need to continue that loop?
Yeah, I think that's a great question. That's from Stephen Sander, is that right? So this, I think when we're talking about a statewide, nationwide, this is, we had the advantage of working with Ramel at US EPA on something called the Escape Trash Assessment Protocol, which is designed to be a uniform, nationwide trash monitoring protocol that can be used in any habitat across any geography. And it's, I think it represents a major stride forward. So if you want an example of a protocol that is more generalized like that, you can look to ETAP, and it's featured in an appendix on the playbook. So please, Stephen, you can look to that. There are some challenges, though, in having what may seem like a perfect apples-to-apples comparison across all habitats and all landscapes and all geographies does come with some complications. And it was great to see US EPA be so responsive to our evaluation of ETAP as we went out in the field, and we ran into some challenges in trying to apply it in ways that would be practical for your conventional trash monitoring practitioner. So we did provide a whole report that provided feedback on that, which you're able to see soon enough. So that's getting to a part of your question. But when you're talking about pushing evidence-based policy development forward, I think it's important to have a sense of the effectiveness of management actions. I think that's kind of where we are often living, and we're unable to say how effective this particular action is over in this area versus this other area if we can't compare one method to another, if they are close cousins even. So having this playbook, we're hoping, can help to chart the relationships among and between the methods, so that we can do crosswalking and be able to get to that evidence-based information, which can then, I would hope, push policy or management action forward. But having a clear sense of what is very important to have in mind before you can even try to achieve what can be. So I know that's kind of a generic way to approach it, but we're more in the science side than on the policy side, so that's what you can expect from on the science side.
Thank you, Tony. For those of you that have more questions, want to get more involved with trash monitoring, especially here in California, I'd encourage you to join the Trash Monitoring Work Group. It's a work group under the California Water Quality Monitoring Council. Tony, will there be an announcement next week when your playbook is web published?
Yes, we will issue the newsletter, the trash monitoring newsletter from the site. So if you stay tuned to that, and if you're interested in getting that announcement, then we would encourage you now to go to trashmonitoring.org, sign up for the newsletter, so you can get all the latest on the trash monitoring playbook and anything else that happens in the trash monitoring work group that will come down the line.
Thank you. Do we have any other questions? You can send them via the chat, or you can unmute yourself and ask your question. If not, I think we'll wrap things up. And Tony, we just received in the chat posting for best management practices for the trash. ETAP will be available soon.
That's right. So Ramel with US EPA is still revising, or it's going through the last round of review before ETAP will be released. There's also a link within the playbook to this, so if you missed that particular link that Ramel has shared, you'll find it within the playbook, prefiguring the appendix that talks about ETAP. So we've already embedded this link in the report.
Awesome, thank you. And Tony, Shelly, thank you for this very, very informative presentation. Do you have any other comments you'd like to close with, Tony, Shelly?
Just to say that we really appreciate the opportunity to chat with all of you. This has been a real rewarding project, and it was done in collaboration with so many people, including, just to call out a few, being all the people on our TAC. We also had the cooperation of BASMA, the Bay Area Stormwater Management Agencies Association, as well as the SMC, the Stormwater Monitoring Coalition. So without their participation in our field work, we really couldn't have done it. So just wanted to make sure we acknowledge that, as well as our funders, such as the Ocean Protection Council and US EPA and the Department of Public Health. So thank you very much.
Yes, and thank you, Eric, for holding this. Appreciate it a lot.
Yes, absolutely.
You know, my pleasure. I'm glad that we'll be able to continue these conversations through the summer. We have lots of additional content and some fantastic speakers. If you enjoyed today's presentation, please go to the California Water Quality Monitoring Collaboration Network webpage. You can download all the information regarding those presentations. And again, please sign up for the emails coming out of the Trash Monitoring Work Group, and then also at trashmonitoring.org, the site that is hosted by SFEI. With that, thank you, everybody. Have a great afternoon and an awesome week.
Thank you so much. Goodbye, and take care.